In this video, we're going to build a very simple digital circuit. We're going to begin by creating a circuit to test the NOT gate, the AND gate, and the OR gate. If they're working properly, we should be able to verify their truth tables using this breadboard. First, begin by finding the NOT gate. Remember that the NOT gate, also called an inverter, has the part number 7404. Locate that chip from your kit. Also, make sure to locate the semicircle or the half moon on the top of the chip. The semicircle should be facing the left. When you place it in the board, you're going to want to bridge the divider in the middle of the board. Do not place the chip up here or down here. It should bridge the middle of the board. So I'm going to start by putting my NOT gate up here. I'm going to leave space because eventually I'm going to add my AND gate and my OR gate. So I'll put the NOT gate right up here. And you're going to gently press the gate into the board, making sure that each pin is directly connected to a hole. Make sure that there are no bent pins. Make sure that the chip is flat and pushed all the way down into the board. Now, remember that each hole in a single row, they're all connected. So I can put a wire in any one of these holes if I want to connect to pin 1. I can put a wire in any one of these holes if I want to connect to pin 7, and so forth. So the next thing that I'm going to do is connect this chip to both power and ground. Remember that no digital circuit can work without each chip having power and ground first. To supply power, we're going to use the 5-volt source right here located on your board. Any one of these 4 holes provides 5 volts, and you can use that at any time you want to, whenever you need to supply power. So the first thing that I'm going to do is take a wire, put it in any one of these 4 holes, and make sure that you push it down in there firmly so that it has a good connection. From there, I'm going to connect the power to the vertical positive bus, which is the red bus, or the one identified with a plus sign. Remember that every single hole in this entire row is connected together. So once I supply power from here to this bus, I now can get power using any single one of these holes. Now I'm going to supply power to the chip. Remembering to look at your pin diagrams, pin 14 is the pin that we are going to connect to VCC or power. So I'm going to take a wire, connect it to the vertical bus, and also connect it to pin 14. Now be very careful that you get pin 14. These holes are small and it's easy to miswire by putting a wire in, say, pin 13, or putting a wire right on this hole right here, which is technically empty. So be careful that you actually have power right in pin 14. Look very closely and double check. The next thing that we're going to connect is also ground. These 2 black terminals on your board here can be used for a ground connection. Notice it's labeled on the top and has the symbol for ground on the bottom. So to connect ground, you're going to unscrew the black cap, take a wire, and place the wire down underneath the black cap so that it has a firm connection, and screw it back on. Once that's done, you're going to connect ground to your negative vertical bus. In order to keep things clean and simple, make sure that power and ground are on alternate sides of your board. That way it's less likely for you to mix them up. So I have ground connected here, and now I'm going to connect pin 7 of the NOT gate to ground. So I'm going to take a wire, place it in any one of the holes for pin 7, and connect it to ground. I have to start with these steps before I can do anything else, otherwise this inverter will not work. It must have power and ground in order to work properly. So with any chip, no matter what types of circuit you're building, you're always going to start by placing the chip on the board across the middle divider and adding power and ground. Next, I'm going to connect an input. Whenever we build a digital circuit, your inputs will always come from these switches, the data switches. The switches represent a 0 or a 1. When the switch is down low, that represents a 0, and when it's up high, that represents a 1. When this switch is down low, it's like sending 0 volts, and when it's up high, it's like sending 5 volts. 0, 1, 0, 1. So our switches are going to be our inputs, similar to how we had switches when we did the multisim demonstration for this circuit. So you can use any one of these switches that you want, it doesn't matter. Notice that each switch has a number and it also has a corresponding hole that you'll connect to. So if I want switch 0, for example, I'll put a wire right in that hole right there. So anytime we have an input, inputs are always going to come from switches. So look back at the pin diagram for the inverter and you'll see that pin 1 is an input and pin 2 is the output. So I'm going to connect pin 1 to a switch. And again, you can pick any switch you like. I'm going to pick switch 7. So pin 1 is connected to switch 7. So anytime that switch 7 is up high, it's sending a 5-volt signal to pin 1. And anytime switch 7 is low, it's sending a 0-volt signal to pin 1. Now the output of an inverter is pin 2. Outputs will always be connected to LEDs, just like we had a probe in the multisim demonstration. So anytime that the LED is on, you know the output is high. Anytime that the LED is off, you know the output is low. I'm going to connect pin 2 of my inverter to LED number 7. And at this point, I'm now ready to test the inverter and make sure that it works properly. Just to recap, we had to place the inverter on the breadboard, connect power and ground. Power was connected to the positive vertical bus from right here. Ground was connected to the negative vertical bus from right here. Once we have power to pin 14 and ground to pin 7, we connect our inputs and our outputs. Inputs come from switches, outputs go to LEDs. Once you're ready to test your circuit, simply flip this button to turn the circuit board on. And notice LED 7 is on. Now you have to ask yourself, does my output make sense? Right now, switch 7 is connected to pin 1 of the inverter. That's the input. So right now, switch 7 is low. A low goes into the inverter and a high comes out. So the inverter is doing its job. It's inverting. I can now take switch 7 and make it high and see that the light goes off. So we can confirm that this inverter is indeed working. If you look at the pin diagram for an inverter, you'll see that there are 6 inverters in one chip. I used the first inverter using pins 1 and 2. I could, for example, use pins 3 and 4 instead. Pin 3 is the input, so pin 3 would go to a switch. Pin 4 is the output, so pin 4 would go to the LED, and I can verify that that inverter works as well. When the input is low, the output is high. When the input is high, the output is low. So my inverter is working. Next, I'm going to test the AND gate. To do that, I'm going to place the AND gate on the breadboard. Make sure you have part number 7408 and place it on the breadboard. Again, make sure that there's one pin in each hole, make sure there are no bent pins, and that it's in the middle of the board. This chip also needs power and ground, just like the inverter did. Since I have power going to my positive vertical bus and ground going to the negative vertical bus, all I need to do is grab a wire and attach pin 7 to ground, and pin 14 to power. Now I'm ready to connect inputs and outputs. Go back to the pin diagram for an AND gate and you'll see that it has 2 inputs. That means we're going to need 2 switches. So I'm going to take the switches from the NOT gate and recycle them over here. So I'm going to connect switch 7 to pin 1. Pin 1 is right here. And remember, an AND gate has 2 inputs, so I'm going to need 2 switches. So I'm also going to use switch number 6. And I'm going to connect that to pin 2. So I have 2 inputs going to the AND gate. One from switch 7, one from switch 6. The output of the AND gate is pin 3. That's the pin that I'm going to connect to an LED so that I can see the output. So I'm going to take a wire and go from pin 3 to an LED. And now I'm ready to verify that the AND gate works properly. So let's turn on the board and begin testing it. Now remember to go back to the truth table that we discussed in prior videos, because that truth table tells you how the AND gate is supposed to work. According to the truth table, when both inputs are low, the output should be low. If one input is low and one input is high, the output should be low. If one input is high and the other is low, so if we reverse it, one input is high and one input is low, the output is low. And when they're both high, the output is high. So this proves that the AND gate works according to the truth table. The last circuit that we're going to build is the OR gate. So locate your chip 7432, that's the part number for the OR gate. Locate that chip and place it on the board. Remember, the semicircle, the half moon, should be facing to your left this way. That way you'll always know where pin 1 is. So place it onto the board. Make sure that no pins are bent. Sometimes you have to line it up just right to get it to go into the board. Press down firmly and make sure it has a good connection. And then we're going to supply power and ground from our vertical buses. Power goes to pin 14. Remember, I could use any hole along the vertical bus, so it doesn't matter which one I picked. Ground goes to pin 7, and again, any hole along that vertical bus, the blue negative vertical bus, any hole. And then I need my switches for my inputs. So go back to the pin diagram for the OR gate, and you'll see that pins 1 and 2 are inputs. So I'm going to borrow my 2 switches here, which are already set up for me, and I'm going to make switch 7 input 1 and switch 6 input 2. And I'm going to borrow the LED from here and just move it over to the OR gate. According to the pin diagram, pin 3 is the output. So I'm going to take a wire and connect it to pin 3. And now I'm ready to test the OR gate. Turn on the board. So according to the truth table for an OR gate, when both inputs are low, the output should be low. If one input is low and the other is high, the output should be high. If we reverse that and make the first input high while the second is low, the output should still be high. And when we turn them both on, the output is high. So this verifies that the OR gate is working properly. So at this time, go ahead and take a few minutes to play around with the NOT gate, the AND gate, and the OR gate. Use a different set of pins. For example, we used pins 1, 2, and 3 on this OR gate. Use pins 4, 5, and 6. Or use pins 13, 12, and 11, and make sure that it works the way you expect it to. This is the end of this video.